So let's see what the tangent is going to look like. First, let's rewrite this. Let's make this y equals sine of x over cosine of x. All right, this is going to help point us in the right direction. It's going to help us get the key parts of the graph. First, the graph has x-intercepts, right, crosses the x-axis, wherever the sine is 0. So that happens at x equals 0, x equals pi, that's about here, x equals 2 pi, which is about here. Okay, and then it repeats on the other side. Let's get the other side in here too. So I'm going to do negative pi and negative 2 pi. Okay, so there are my x-intercepts. It's going to have asymptotes wherever the cosine is equal to 0. Right? That happens at pi over 2, which is right here in the middle of this interval. And it's going to happen here at negative pi over 2. And it's going to happen in the middle of the next interval as well. This is 3 pi over 2 and negative 3 pi over 2. So let me label these. X equals pi over 2, 3 pi over 2, and then the negatives. Negative pi over 2 and negative 3 pi over 2. All right, so let's think about what the actual graph does. What does it do in this first interval between 0 and pi over 2? Well, that's the first quadrant. And in the first quadrant, the tangent is positive. So it's going to start off at that intercept and take off up here toward the asymptote. Now, what happens on the left side? Okay, that's the fourth quadrant. And in the fourth quadrant, the tangent is negative. So that is what our tangent function looks like. And that's an entire period. Negative pi over 2 to pi over 2, that's pi. That's an entire period of this function. So in each of these other sections, I'm just going to duplicate that same. I'm going to do a better job of duplicating. I'm going to duplicate that same shape. Right, and let's get a little more in here since I got those intercepts in there. Right, it's going to go here, and it's going to go here. Right, that's what our tangent function is going to look like. Okay, so everything else we know, phase shifts, amplitudes, all the rest of that, are going to behave exactly the same way. Just keep in mind the period of the tangent is pi and not 2 pi. So here, the amplitude will be 3, and the period will be pi divided by 2. Okay, so what's that mean? Well, there's no phase shift here. So the first x-intercept stays at 0. Now, these x-intercepts, they repeat every period. So if I go over pi over 2, right, I get another one. And if I go over pi over 2 again, if I go over to pi, I get a third. And if I go in the other direction, if I go to negative pi over 2 and negative pi, I get intercepts. The asymptotes are halfway in between them. Right, so I had my first one at 0 and my second one at pi over 2. That means the first asymptote is here at x equals pi over 4. And then I must have another one here at negative pi over 4. You notice, what's the distance from negative pi over 4 to pi over 4? Well, that's pi over 2, which is a period. Excellent. That's exactly what I expected to see. And now I'll do a couple more here, right? If I go over pi over 2 again, I get one here. This is 3 pi over 4, And then I get another one here on the left side at negative 3 pi over 4. And how do you do the 3? Graphing the amplitude is tricky when all we're doing is sketching. It means the graph is going up faster. It's a little difficult to draw, right? So the best I can do is just kind of make it slightly closer to a straight line. Remember, we're just sketching these things anyway, right? There, and I'll do one more there, right? Something like that. That's what 3 tangent 2x looks like. Okay, last one. Cotangent function. We can think of the cotangent exactly the same way. This is cosine of x over the sine of x. So anywhere the sine is 0, we get a vertical asymptote. So we're going to have one at 0. We're going to have one at pi. You notice that's going to be one period there, right? We're going to have another one at pi over 2. And these will repeat on the negative side. We'll have one at negative pi. And we'll have one at negative pi over 2. So let me go ahead and label those. X equals 0, x equals pi, x equals 2 pi, and the negatives, negative pi and negative 2 pi. Okay, so the intercepts are occur wherever the cosine is 0, and that happens halfway between, right in the middle of each asymptote. So I've got one here at pi over 2. I have another one here at 3 pi over 2, and negative pi over 2, and negative 3 pi over 2. And now we can sketch the graph, right? But you got to be careful. Think about positives and negatives. In the interval between 0 and pi over 2, that first intercept, the cotangent is positive. So the cotangent is going to start high and drop down low and go through the intercept, right? And now, right, this whole thing, these are just periods. So it does the same thing over here, the same thing over here, and again, the same thing here. Right? So that's what our cotangent graph looks like. All right, so let's try one more. You can pause and practice this one if you like. Then we'll do it together. Okay, so let's see. My amplitude is 2. My horizontal shift is down 1. That's the negative 1 at the end. I have a reflection across the x-axis. That's the minus part. And the period is very tight. Pi divided by 4. Okay, so let's see. We have an asymptote at, my first asymptote will be at 0. There's no phase shift, so that hasn't moved. Then my next asymptote will be 1 period over. That's going to be a pi over 4. What's pi over 4? 3 divided by 4 is 0.75, so it's a little more than that. It's here kind of close to 1. And then I'll have another one at negative pi over 4. And it's going to squeeze into these, right? So my next one will be at, let's see, my period is pi over 4, so just keep adding pi over 4. Pi over 4 plus pi over 4 is pi over 2, which is a little more than 1.5. And then we get another one here at minus pi over 2. All right, let's see if we can squeeze these in now. So, what is the amplitude? Well, it's 2, which, like I said, is hard to draw, but it's going to kind of do a stretch. And then there's the negative. So that's going to flip it. So now instead of going like this, right, now it's going to flip and go like this. And the roots all get decreased by 1. So normally the root would be halfway between these two intervals. So it would be halfway between 0 and pi over 4, which is pi over 8. But that's going to be shifted down 1. Right? Let's see. So, and it's going to repeat. It's going to be like this in all of these sections. And then I'm going to try and draw. Right? I'm going to start at the asymptote, come up to that point, and go all the way up. And it's going to do this over and over again. That one got a little sloppy. Sorry about that. There you go. That's what your graph looks like. Okay. So now where are we going? We've covered a lot of territory at this point, right? We really have. So where we're going to go next is we're going to start talking about some applications of this thing, the applications of trigonometry to things like vector analysis. If you've ever done a physics class, you've talked about vectors there. And we're going to also talk about, and this is going to be really kind of surprising, we're going to talk about applications of trigonometry to complex numbers. Trigonometry is going to let us do some operations with complex numbers that were very, very tedious much more quickly than we could in the past.